Okay, geometry. New chapter, new section. So we've got 10-1 lines and segments in circles. And so let's just get a basic circle up here and let's start throwing some information on it. Okay, so we've got all of our basics. We know that the distance, actually let's go very basic. Let's start with, and I almost want to, but it's not going to be up there. Okay, let's go very basic. And let's go center of the circle. And then our diameter. Boy, I'm not going to get that very good, am I? Let's try that. That's pretty close. You know how we can fix that? We'll just do this. And put that as our center. Okay, so I'm actually going to color over this. And so our red is going to be our diameter. And then if we had a segment that went from the center to the outside, I'm going to put that in blue. And that's going to be our radius. Okay, so these are not new material. This is not new material for us. Now we're going to go with something that doesn't necessarily go through the center. So let's say we have that segment right there, and I'm going to color that in green. That is called a chord. Okay, a chord has its endpoints on the circle, but it does not go through actually, it could go through. A diameter is considered a chord, so it just has its endpoints on the circle somewhere. A radius would not be considered a chord because it only goes from the center to the outside. Okay, so center, and I could label that a little bit better. Dun, 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 dun. There we go. There's our center. So center, diameter, radius, and chord. And remember, we remember the relationship of a diameter and a radius. So the radius is 1/2 of the diameter. And so now we're going to look at some different processes. So let's talk about tangents. Okay, let's talk about circles that might be tangent to one another. Circles that are tangent to one another share a common intersection point. For example, if I had this circle and this circle, they don't intersect anywhere. However, if I took the second circle and I moved it here, then I would now have a point of tangency. Okay, a point of tangency. I could also have, I could take that same example. So I'm going to go ahead and erase mine, but you'll still have yours there. I could take that same circle and I could move it here, and I could have 2 points of tangency. Okay, so it could intersect twice. And if I go back to my first one, again, I'll erase these and you keep yours on there. If I go back to my first one, and I just have My two centers there looks like a donut. Okay, so if you're watching this in the morning, hope you're having donuts for breakfast. If you're watching at night, maybe you're having donuts for supper. I don't know. So these, because they don't have a point of tangency or 2 points of tangency, these are called concentric circles. Okay, concentric just means that they do not intersect on the endpoints anywhere. Okay, I want to rewind. I made a mistake, and I want to go back to an example. And of course, I erased mine, so I'm just going to recreate them. So if I had two circles like this, and I talked about that, and I called that a point of tangency, that was incorrect. This is a point of intersection, just an intersection point. So let's go ahead and go back on your notes and correct that on the first one. That's just an intersection point. And then on the second one, it would just have two intersection points. So we're going to get into some tangent options here in just a minute, and I made a mistake on that one. So let's look at some points of tangency. If I have, let's go two circles again. Let's say I have something like that. And I want to find as many points of tangency as I can. So I want to draw lines, and I want those lines to hit, or line segments, we'll call them lines, but they don't go on forever. And I want to, that's a horrible drawing. However, let me go back. There we go. If I were to draw a line like that, and a line like that, so these are what's called common tangents. Each one of the circles shares, and it hits one time. I can also draw, and these are going to be a little bit more difficult. See if I can get this. I can also draw common tangents this way. Make that one a little smaller. I don't like that drawing. That's a little bit better. Okay, so anytime that I can draw a segment and it can intersect both of them, that is a common tangent. So this one has 4 common tangents. Okay, so I have 2 on the outside, and I have 2 that are internal. Now, what's an example of where I might not have 4? If I could have 2 circles that just have if I just have 2 circles that have 1 intersection point, let me fix that just a little bit. Since they have an intersection point, I won't have those 2 in the middle. However, I do have my ones on the outside still. Oop, I don't like that. I do want it to make it look like it's, so I've got that one, and I've got that one. Okay, so this one would have 2. Nope. This one would have 3, because I could have one that went like that, couldn't I? So this one's going to have 3 common tangents. Now let me get to the 2. Now if I had something like that, I can't have anything go through the middle. And so I would only have 1 and 2. So in that case, 2 common tangents. little better A there. Okay, so I just drew a 4 common tangent, 3 common tangent, 2 common tangents. So let's go back to our concentric one from a little bit ago. Would our concentric circles have common tangents? Remember that it has to intersect the outside only one time. And in this case, if I were to draw a line, okay, and I was to draw it one intersection point there, this one would actually go through my circle and not be resting up against it. So in this case, concentric circles are going to have no common tangents. Okay, so let's talk about what a tangent actually does. A tangent in a circle, let's say I had one that went right there. A tangent creates a 90-degree angle. Let's say I have my center right there. A tangent creates a 90-degree angle with a radius or a diameter, either one. And so what they're going to use that for in this chapter is maybe determining, trying to find maybe the radius length. And so let's say that this is 35. The tangent is 35, and then that hypotenuse is 37. So the whole thing is 37. How could I find the radius? And so using what we know in a right triangle, we would have x squared plus 35 squared equals 37 squared. And so I'll get my calculator here real quick. That's going to give me x squared, and 35 squared is 1,225, and 37 squared is 1,369. And so then I'm going to subtract the 1,225 from both sides. Giving me an answer of x squared equals 144, which means x is technically plus or minus 12, but we know since it's distance, it has to be positive 12. So x would equal 12. So every time you have a tangent to a circle, it makes a right angle with either the radius or the diameter. Now, we also have what I like to call the ice cream cone effect. And so if I had a circle like this, and then I had two tangents, I'm not a very good ice cream cone maker, but you can see what I'm doing here. If you have two tangents that are drawn from the same point, let's say this is point A down here, and that intersection is point B, and that intersection is point C. If you have two tangents that are drawn from the same point, that means that they are congruent. So AB is congruent to AC. And think about your ice cream cone. If the two sides of your ice cream cone were not the same size, or were not congruent, then your ice cream cone would not sit on it straight. It would sit to an angle. So there's some properties of lines and segments in circles. That's 10-1. That is all.